So for the first one here, we're doing 8 plus a quarter. We're doing 8 plus a quarter here. That's hopefully one of those easy ones, because you don't have to, strictly speaking, go through the whole process of turning 8 into a fraction and then finding the common denominator and all that, although you could. But since we're just doing a whole number plus a fraction, it is just 8 and a quarter. Because that's what 8 plus a quarter means, is it means 8 and a quarter. All right, then we're doing 8 minus a quarter. Now again, we can reason it out, but let me give you a different way of looking at it, just because I figure the more tools you have, the better off you are. Here's 8 wholes. I'm subtracting off a quarter. So that part's been cut out of this whole thing. How much is left then? Well, how many wholes are left? 7. With some left over, how much of this last one is still left? 3/4, because we took 1/4 of it away. And so it's 7 3/4. All right, next up, 8 and a fourth. And again, we could do the whole process of turning the 8 into a fraction and then multiplying across the top, multiplying across the bottom. Or we can say, wait, a fourth of something is just dividing it by 4. What is 8 divided by 4?
2.
That's our answer. And then finally, 8 divided by 1/4. While you're still getting a really good feel for this, I suggest you actually write out the work on it. Because otherwise, if we tend to just go on intuition, it tends to lead us into thinking the answer is 2 here, and it's not. So, showing the work of how we could actually get that, I would do 8 over 1 times 4 over 1. Because we always flip the second fraction. And so if I'm doing 8 over 1 times 4 over 1, that's really just the same thing as doing 8 times 4. So, what does 8 times 4 equal?
52.
And that's the answer there. All right, next up today, we're going to be reminding ourselves how logarithms worked. So we're going to be doing some practice with the logarithms. So to start with, I want you to write a few things on your paper there. First, write down our definition, our notes here, just so you have that handy for future problems as well. And then once you've written that down, write down the 3 problems here, and then we're going to work those 3 out together. So for the first one here, we're going to change log base 3 of x equals 4 into exponential form. Now as you look at the notes up at the top here, that basically means we're changing it from this into this, because this is what's called exponential form there on the left. Exponential means it's something with an exponent in it, basically. So, what we're doing is we're going through and we're basically saying what is playing the role of what here. So the first thing I write when I write my exponential form is the b. So I go over to my log form here and I see where does b show up. B stands for base. That's why we use b there. It is the small, low number written immediately after the g. So in the case of this first problem we're doing, the base is 3. So I write it as 3. Then next up is x. Now of course that doesn't have to be the same as the x in our problem here. This x comes from this x over here. So the exponent then we can see is whatever the logarithm is set equal to. It's the number or the letter that's by itself on the other side from the logarithm. So in this case then, that's the 4. So it's going to be 3 to the power of 4. Then the next thing we put into our equation here is the equal sign. And then the y. Notice where y comes from here. Y is the full-sized letter or number that is after the base. So in this case then, that's where the x is. So this is going to be 3 to the power of 4 equals x. And then that's our answer. Because all we're asked to do here is rewrite it as an exponential. We've now written it as an exponential. So that's our answer for that first. We're going to use the same basic process for doing the other 2 here. So let's work through those. All right, next one. First thing I write in there is the b value, the base. My base in this one is x, because the base is whatever that lower, smaller font is. All right, then the next thing is it's to the power of x, which comes from whatever log equals, because log always equals the exponent. So in this case, it equals 2, so it's going to be x to the power of 2. Then our equal sign, and it equals y. Notice where the y comes from. It's right after the base, so in this case it is 16. So we got x squared equals 16. And then finally, for this last one, we got log base 6 of 36 equals x. The base that I write first here, whatever's raised to the power, that is going to be the base of our logarithm, 6. Log always equals the exponent, so my exponent must be x. And even if you don't remember where the y sits, process of elimination will tell you what's left. The 36 is the only one we haven't used yet, so it's got to be 6 to the power of x equals 36. That's all we are asked to do for each of those 3 problems. Now, I'm going to take you a few steps further, because each of these are actually ones that we could solve and figure out what x is. So I just want to take a moment here and actually look at how would we find each of these values for x. All right, first step, the 3 to the 4th equals x. Well, 3 to the 4th just means 3 times itself 4 times. So it's like that. Now, I want to actually calculate out what 3 times 3 times 3 times 3 gives me. But if I did that by doing 3 times 3, and then multiplying that by 3, and then multiplying that by 3, I end up with some bigger, uglier numbers. A trick to do this one that makes your life a little bit easier is instead of doing 3 times 3, and then that times 3, and then that times 3, 3 times 3 gives me 9. The other 3 times 3 gives me the other 9. And I know what 9 times 9 is. 9 times 9, of course, is 81. So there we were able to figure it out. Much easier than if we had multiplied 3 by 3 is 9, by 3 is 27, and then 27 times 3 would give us 81, but that's a bit harder to figure out. All right, now for the next one. X squared equals 16. I want to know what x equals. How do I get rid of the squared? Square root. And so I take the square root of both sides there, and I can find that x equals 4, although there's something else supposed to be in here. Yep. Remember that when we take the square root of both sides of the equation, we have to account for both the positive and the negative. So you can write your answer either as plus or minus 4 like it's written there, or you can write 4 comma negative 4. They both mean the same thing. All right, and finally, 6 to the power of x equals 36. The only way to actually calculate that value would be by turning it back into a logarithm and then calculating. But we're doing this without our calculator. So this one is chosen because we can actually figure it out intuitively. How many times do you have to multiply 6 by itself to get 36? Twice. And so that's why it is 2. So the next up, I want to practice these 3. Now these 3 are all set up in a very particular way because we're going to be using this going forward. Write down all 3 problems, and then take a moment, see if you can figure out what x equals for all of them. Any of them you can, at least write down the problem and be ready for us to go through it together. All right, so let's do this first one here. We're doing log base 2 of 8 equals x. So the first thing we want to do is we want to think about what's this look like in exponential form. And so again, just like we were doing on the previous ones, the base is 2. Log always equals the exponent, so it equals x, so it's got to be 2 to the power of x, equals 8. Now we need to know what x is. Now some of you, you're going to look at 2 to the power of x equals 8, and you're going to know what it is. Now if not, there's a great little technique for it. Because 2 to the power of x just means multiplying 2 by itself a bunch of times. We're going to figure out how many times it takes. So what is 2 times 2? 4. Okay, that's not it yet. Times another 2 would give us 8, because 4 times 2 is 8. So that's what it took. So it took a grand total of 3 2's, so it has to be 3. 2 to the power of 3 ends up equaling the 8 then. All right, next up, log base 5 of 125. Again, we think about it as the exponential form. And then we have to see 5 times itself how many times gives us 125. So what's 5 times 5 give us? So that's 25. So we're not there yet. If I multiply that by 5, will that give us 125? Yeah. If you're not sure off the top of your head, then you can kind of reason it out. Does it look like it would at least be close to it? And that's a way to clue in. Because we're doing all these without a calculator, right? It's not exactly going to be 2.735 for the value, right? If we're doing this without calculator, I'm going to make them whole numbers for you. And it does turn out that yes, 5 times itself 3 times gives us the 125. All right, and finally, log base 7 of 49 equals x. Okay, so 7 to the power of what equals x? And then every now and then somebody will look at that and they'll be like, oh, that's easy, it's 7. But it's not, because that's 7 times 7. But if we're doing 7 times 7 to get 49, we're actually multiplying 2 7s together. So that's why it's 2. So you've got to get your brain into thinking, how many of this number am I multiplying by itself, rather than what do I multiply it by to get that number. All right, now the reason why I chose this particular selection of problems, all oriented to where they were equal to x, is because reasoning through these helps us figure these out, where there is no x in it. Go ahead and take a moment, write down the 3 problems, then we're going to see how we do them. So in the last set of problems, we saw how we would do it if we had that, if we had it equal to x. But without that there, we can still use the same reasoning. It's just, instead of knowing what we're calling our answer, instead of knowing it's called x, we're still just saying 2 to the power of what would equal 8. It's just, instead of writing 2 to the power of x, it's 2 to the power of, I don't know. And so we actually did that one earlier, right? 2 to the power of what does equal 8? 3. And so the answer here is 3. Now, last time we knew that it was called x. This time there is no x in it, so it's not x equals 3, it's just the answer is 3. And you can write this or not. It is great work to help see your way through it, but eventually I want you to the point where you just look at log base 2 of 8 and know that means 2 to the power of what equals 8. So with that in mind, go ahead and take a moment, figure out the next 2 problems. All right, so for this next one, it's saying 4 to the power of what is 16? The answer is not 4, right? Because 4 times 4 is 16, yes, but this is saying 4 to the power of what equals 16? And it's 4 times 4, so it's squaring it. So it's 2. 4 to the power of 2 is 16. All right, now for this last one, log base 2 of 32. Well, most of you probably are not going to know that off the top of your head. And that's okay. But we can still use that same technique of saying, okay, well, I'm just going to write them out till I get there. So 2 times 2 is 4. Okay, 4 times 2 is 8. Okay, 8 times 2 is 16. 16 times 2 is 32. Okay, I've reached my target. So, how many 2's did I have to multiply to get 32? That's how we know the answer is 5. Now, you then have a nice groove going on these, and you can kind of see a lot of the techniques, but there's a few special circumstances that tend to throw people off a little bit. So we're now going to finish our lesson here with these 3. So write down these 3, and then we'll see how we get each of these answers. All right, so for that first one, we have log base 7 of 1. Remember, we can interpret that as 7 to the power of what equals 1. Well, here we have to remember a rule that deals with exponents. The same exponent will always give us an answer of 1. Do you remember what that is? It is 0. Anything to the power of 0 equals 1. Which means that every single time you see the 1 sitting right there, you know the answer is going to be a 0. All right, next up, log base 8 of 8. So it's saying 8 to the power of what equals 8? How many 8s does it take to make an 8? 1. Yep, so that answer is just 1. So if the base and our number there are the same number, it's got to be a 1. Because anything to the power of 1 is itself. All right, now having done those, you hopefully can do this last one on your own.
0.
20 to the power of what would equal 1?
0.
0. Because anything to the power of 0 is 1.